Today we're going to look at even more trig formulas. But first, a few comments. So, at the suggestion of students, one I thought was a good one, we have a lot of kind of randomly formulas, which I don't think it's necessary to have memorized them. I mean, you should know about them, know how to look them up. When they come up, you'll look them up. So what I'm going to do is I'm going to put together, I guess what you would call a cheat sheet for the final. And I will try and do it over the weekend and post it so you know what's going to be on it. So just, you know, things that I feel like it's perfectly okay to look up. Just as, you can use a scientific calculator and find a sine or cosine. I'm also going to try and put together a practice exam, just something that would give you some, you know, opportunity to go through it and see if what you think you know is what you actually know. I'll try and do that this weekend too. We're going to go over a few more formulas today, and then I have a short video I want to play. I was looking at this video and I was thinking, you know, we're learning all this trigonometry, and it may just seem very abstract. Maybe you need it because you're going to take calculus and you have to take this first, but that's the only meaning it might have. Maybe you don't even take calculus. Maybe this is just a prereq for some other course or some other line of study. So all this stuff kind of seems a little useless. But in this video, you see that in the recent history of the world, it was very significant. It was not so long ago we didn't have satellites. We didn't have a lot of the technology we have today. And so even just looking at the shape of the world was a bit of a mystery. And the video very nicely talks about that. So hopefully we'll have time for that. All right, I wanted to take off from where we left off on Monday, and I wanted to show you that we found the double angle formula for various trig functions. For example, sine of 2x is 2 sine x cosine x. But we can do a lot more with this. For example, if we wanted to find sine of 3x in terms of sine x cosine x, we could just apply this formula directly. you say sine of 3x, that's really sine of 2x plus x. So we need the sum formula for sine. So that's sine of 2x cosine x plus cosine of 2x sine of x. Well, okay, it's not quite where we want to get to yet, but cosine of 2x and cosine of 2x also have formulas, right? Sine of 2x is 2 sine x cosine x times cosine x. And cosine of 2x, that's cosine squared x minus sine squared x times sine x. We could make this look a little better. We work at it. That a factor of sine of x we can take out for now. This is 2 cosine squared of x plus cosine squared x minus sine squared x, or sine of x, 3 cosine squared of x minus sine squared of x. But cosine squared of x we could put in terms of sine, right? Sine of x, 3 times 1 minus sine squared of x minus sine squared of x. And we can expand this. I guess it's time to get a new marker here. 3 minus 3 sine squared x minus sine squared x. So what does this give us? Sine of x times 3 minus 4 sine squared x. Or finally, this is all equal to 3 sine of x minus 12 sine cubed x. I feel like I made a mistake somewhere here, but that's okay. Maybe I did, maybe I didn't. Where did I get 12 from? That's not right. Okay, so you can use these formulas. You could build up sine of 3x, sine of 4x, cosine of 3x, cosine of 4x, tangents. That could be useful under certain circumstances. But what we're going to do next is actually a little more useful. We're going to take a look at the half angle formulas. So what we want to do is we want to come up with some formulas for cosine of x over 2, sine of x over 2, and tangent of x over 2. But we're going to start with something we already know. We're going to start with, again, with the double angle formulas. Start with cosine of 2x equals 2 cosine squared x minus 1. Well, if you think about it, we're starting with the cosine of x here, we get out of it the cosine of 2x. Okay? But if we go in the other direction, we're going to get what we want. Right? In other words, if I can start with cosine of 2x and I get back to cosine of x, that's finding half the angle. Right? So let me solve for cosine of x here. This is cosine of 2x plus 1 equals 2 cosine squared of x. Cosine of 2x plus 1 over 2 equals cosine of x, cosine squared of x. And now I'm gonna find the square root of both sides. And I'm going to get cosine of x equals, and then I have to be careful, right? So this could be plus or minus the square root of cosine of 2x plus 1 over 2. Well, this almost looks like what I want. All I really need to do now is realize that, x is just kind of a dummy variable. If I substitute for x over 2 here, cosine of x over 2, this just becomes plus or minus the square root of cosine of x plus 1 over 2. So that's my first half angle formula. Now, a word on this plus or minus here. Why is there, what can we do about that? I mean, this isn't a function, right? I'm getting two values out of it, but in particular, we're going to know whether it's plus or minus. If, for example, I were to find the cosine of 50 over 2 degrees, right? 25 degrees. I know that's in the first quadrant. So I know it's going to be a plus. But on the other hand, if I was looking at the cosine of, say, 200 degrees over 2, well, that's the cosine of 100. Which quadrant is 100 degrees in? Second. What's the SIGN of the cosine in the second quadrant? Negative. So we can see that this is going to be, we're going to have to use the negative here. All right, that's the half angle formula for cosine. For the half angle formula for sine, we're going to use cosine of 2x again. Except this time we're going to use the form 1 minus sine squared x. So now we have cosine of 2x minus 1 equals minus sine squared x, or dividing by minus 1 or multiplying by minus 1, we're going to get 1 minus cosine of 2x equals sine squared of x. Or, again, finding the square root, we're going to find sine of x is now, again, plus or minus. Oh, I left something out. I left a 2 out. Sorry. 1 minus cosine of 2x over 2. And again, I'll just substitute here. Sine of x over 2 is now plus or minus 1 minus the cosine of x over 2. So that's my equivalent formula for the sine of x over 2. Tangent, it's kind of more obvious how we would find the tangent. The tangent of x over 2 we know is just the sine of x over 2 over the cosine of x over 2. But we've already developed formulas for these two. So we can see that the tangent of x over 2 is going to be what? Plus or minus the square root of 1 minus cosine x over 2 over plus or minus the square root plus cosine of x over 2, which is just plus or minus 1 minus cosine of x over 1 plus cosine of x. All right, let's put that up here. It turns out that there's some nicer forms for this formula that we can get to. We're going to use this trick where try and eliminate 1 plus cosine of x from the denominator. We multiply by 1 minus cosine of x over 1 minus cosine of x, which is, of course, that's just 1. And we get on the top 1 minus cosine of x squared. That's nice. And on the bottom, we have our a plus b, a minus b pattern. So this is 1 minus cosine squared x. But we know how to simplify that. That's using the Pythagorean identity. That's just sine squared x. So we end up nicely with the square root of 2 squares. So we end up with 1 minus cosine of x, sine of x. Now, you might ask, what happened to the plus or minus? Well, if you check x and y in each of the quadrants, you'll find that in all cases this is going to be positive. So another form here is 1 minus cosine of x over sine of x. But we're still not done with this fellow. We can transform him again and get a slightly different version. Again, this time we're going to multiply by 1 plus cosine of x over 1 plus the cosine of x. On top we get 1 minus sine squared x, and on the bottom sine of x times 1. Is that what I wanted to do? I think it is. 1 plus cosine of x. Worked in the first class. I'm just slow today. Well, no, that's not what I was expecting. All right, I'll try this the other way. Just state that I believe this is sine of x over 1 plus cosine of x, and I'll try and verify it. So sine of x over 1 plus cosine of x times 1 minus cosine of x over 1 minus cosine of x is 1. So on top I get sine of x times 1 minus cosine of x, and on the bottom I'm going to get 1 minus cosine squared x, which of course is just sine squared x again. Sine of x over 1 minus cosine of x. But I can eliminate a factor of sine of x, so this is 1 minus cosine of x over sine of x. So that's just the third form that we might see tangent half angle formula. Sine of x over 1 plus cosine of x. All right, let's at least take one stab at seeing why this might be useful. I think we did this same problem a little differently. What I'd like to do is I'd like to find out what the sine of 15 degrees is. Exactly. No round off. Well, I know that the sine of 15 degrees is the sine of 30 degrees divided by 2. I can use my formula, which tells me this is 1 minus the cosine of 30 degrees over 2, square root. 15 degrees, we know which quadrant that's in. It's the first quadrant. So the sine of 15 degrees has to be what? Positive or negative? Now you should all be jumping out of your seats, yelling positive, right? First quadrant. So I can just get rid of the minus here. All right, this is the square root of 1 minus the cosine of 30 degrees. What's the cosine of 30 degrees? Just think about that. 30-degree angle. This is 1, this is a half. Root 3 over 2, and the cosine is the adjacent over that mix. So it's root 3 over 2. Okay, I can play around with that just a little bit, but there's not much I can do. It's kind of ugly looking, but it is an exact value. So, you know, in principle, you could use this half angle formula to break down. We could go 15 degrees, 7.5, 3 1/4, as far as we want. We've got addition formulas. We could actually pretty much create any rational trig functions on any rational number. We could come up with an exact expression. They would get progressively more complex and have more and more embedded roots. But at least in principle, we can do that. And then, as you will you'll learn in calculus, if we can find all the rational values, we can approximate any irrational value as close as we want. But we have calculators that do that for us, so we're not all that interested. Just nice to know. Okay. Any questions on half-angle formulas? All right, we're going to try and develop a few more formulas here. Product to sum and sum to product. These are just what they sound like. We want a formula that takes a product and gives it to us just as a sum of values. So the first one we're going to look for is sine of x times cosine of y. We'd like something in terms of some kind of sum on sines and cosines. We find this by taking this expression, sine x plus y, and adding it to sine of x minus y. Okay, how is that going to help us? We know this is sine x cosine y plus cosine x sine y. That's the first part here. And the second part is sine x cosine y minus sine x cosine y. We can see that these two terms are going to drop out. And these two terms are the same. They're just 2 sine x cosine y, which is equal to this. So we can see that this formula is going to be sine x cosine y equals this expression, sine x plus y plus sine x minus y over 2. So that's our first product to sum formula. Three more of these formulas. I think I'm just going to, I'm going to show you what they are and how we would get them, but I don't think it's necessary to repeat. Cosine x sine y, that's going to be sine of x plus y minus sine of x minus y over 2. We kind of see how this is going to work. Instead of adding this expression, we're going to subtract it. So the first term is going to drop out, and the second term is going to be a duplicate of this. Did I write that wrong? Sine x cosine y cosine x sine y. If you're taking meticulous notes, you want to be careful with what I put on the board today. To get the other two, which are cosine x, cosine y, we're going to do the same type of thing we did here, except instead of adding the sines of sum and difference, we'll add the cosine of sum and difference. And we'll end up here at cosine of x plus y plus cosine of x minus y over 2. It could be worth your while to try one of these, just to see how they work out very nicely. And then finally, we can find sine of x, sine of y in the same way, but now subtracting these two. So those are our product to sum formulas. And this is the kind of thing I'm just going to provide for you on the exam. There's going to be some homework where you'll have to use these to do some stuff. We'll show an example in a minute. But, that's the product to sum. The question is, if we want to go backwards, how can we do that? Let's start with the first formula we came up with. Sine of x cosine y equals sine of x plus y plus sine of x minus y over 2. To convert this to a sum to product formula, we're just going to do a very simple algebraic substitution here. I'm going to set x equal to a plus b over 2 and y a minus b over 2. Now looking at this, if I add x and y, what am I going to get? I'm going to get, the b's are going to drop out and I'm just going to get a. So x plus y is going to equal a, and similarly, x minus y will equal b. So let's use these substitutions up here. This tells me that the sine of a plus b over 2 times the cosine of a plus b over 2 will just be sine of a plus the sine of b over 2. Well, that's almost what I want. I want a sum to product, so I could write that as sine of a plus sine of b is 2 sine of a plus b over 2 cosine of a plus b over 2. And since we usually don't write these with a's and b's, let's just put back our x's and y's. Let's say sine of x plus sine of y equals 2 sine of x plus y over 2 cosine of x plus y over 2. All right, so now we have a sum to product rule. Write that over here. So we have 4 product to sum rules. Using this same substitution, we're going to end up with 4 sum to product rules. In particular, I want to write this one down. We're going to find that the cosine of x plus cosine of y is 2 times the cosine of x plus y over 2 times the cosine of x minus y over 2. And let's look at an example where this might be useful. I wanted to take cosine of 3x and add it to the cosine of 7x. And I want to express this as a product. So how could I do that? Well, my formula tells me that this will equal 2 times the cosine of 3x plus 7x over 2 times the cosine of 3x minus 7x over 2. Simplify that a little, 2 times the cosine of 5x. And this is the cosine of negative 4x. We could simplify the cosine of negative 4x, can't we? Because cosine is what kind of function? I can't hear you.
Even?
Even. Yeah, this is just cosine of 4x. So we end up with cosine of 5x times the cosine of 4x. Okay, so these are useful for, homework problems and other things. All right. What we're going to do is we're going to take a look at this video. As I said, it kind of, well, it's about a little bit about trigonometry. There's some trigonometry. There's a little geography, a little map making, some mountaineering. I think it's really cool because it shows you that it's only very recent that a lot of the things we take for granted that technology has provided have come about. I guess I should just play the video. It's short. It's only about 5 minutes. It kind of speaks for itself. Let's see. wonder why there's no volume. Volume control is turned all the way up. Volume on my computer is turned on. Let's see, is there? Oh. I have not run into this before. Oh.
Besides,
Aha. Okay. We're almost there.
to make a map like this,
So, yeah, so just a couple hundred years ago, we didn't even know what India looked like. And, we were out there with our telescopes and sticks measuring. Any questions about the video? If not, I'm going to just have to say have a nice Thanksgiving break.